Welcome. Today's lesson is a review of trigonometry. So first we're going to use the definition of all 6 trigonometric functions using triangles. Then I'll show you how to use a calculator to find most of the values, or at least some values. You can sort of complete the ideas yourself. For calculus, we only use radians. It's important, if you're going to use your calculator, to get it out of degree mode and never put it back. And then we'll talk very briefly about the graphs, the periods of the functions, mention the inverses, and then show a few identities, trigonometric identities. There are millions of them, and we only need a few. So, first, here are the 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. In terms of a triangle, if this is the angle for a right triangle, the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. Hopefully you can see all of these. There is a mnemonic for the first 3 that you may have heard of, SOHCAHTOA. It's useful. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. The last 3 are not in there because the cosecant is 1 over the sine. The secant is 1 over the cosine. And the cotangent, well, because of its name, hopefully you can tell, it's 1 over the tangent. So if you know the first 3 and you remember that, you can find any of them. Now, when it comes to actually finding values, we plug them into our calculator. Or we know them by heart. There are a couple we'll know by heart, but some we won't. The sine of 2. Remember, this is 2 radians. Now, if you think about it, where on a circle is 2 radians? The circle is 2 pi, that's about 6, so we're about 1/3 of the way around. We're about right here. The sine, in terms of circles, is the y value, so we'd expect a positive value fairly close to 1. So I'm going to plug it in here, and I'm going to get the sine of 2 is, just checking that I'm in radians, 0.90929. Or if you round, 0.90930. Now the cosine of pi over 4, your calculator should have a pi button, so you could do that, but this is one of the specific values that people learn in a trigonometry class. So this one should be 1 over the square root of 2, or 0.7071. Now, both of these are irrational values, so they go on forever. We use them as decimal approximations. Now the secant, 3.16 is not one of the values we know by heart, so we plug into our calculator, but our calculator does not have a secant button. It has a cosine button. It has an inverse cosine button, but inverse is not the same as 1 over. Notice, secant is 1 over the cosine, so we need 1 over the cosine value. So this is going to be 1 over the cosine of 3.16. So if you do that, find the cosine of 3.16, that's about 0.999 and so forth. Take 1 over it, there's a minus involved. We get minus 1.000169, and there's more digits. Now notice, 3.16, it's very close to pi, just a little bit more. So we're traveling all the way around here, and just a smidge more. So the cosine, which is the x value, is almost 1. So the secant, which is 1 over that, is a little bit more than 1. Now let's look at the graphs. In red, I put the sine x, badly drawn here. In blue, it's cosine, and the green is an attempt at drawing the tangent. The tangent graph has many vertical asymptotes, straight up and downs, that interrupt the graph. It's not evaluated at those points because the tangent turns out to be the sine over the cosine. Sometimes the cosine is 0, so that's undefined. But the sine and the cosine graphs, they sort of look the same. They're just shifted. And if you study these in a lot of time, you'll find that the cosine is in fact a shifted sine graph, or the sine graph is a shifted cosine. There are several shifts you could do. The period of each of these, it repeats. 4 of them repeat every 2 pi, but the tangent and cotangent, because of their peculiarities, repeat every pi. That can be useful if you're evaluating, but this is predominantly a calculus information rather than trigonometry information. So much of this will not be used very often. It's just good to know. Lastly, let's talk about this. Inverses. The inverses of the trig functions. Well, they take what you end with, and they produce what you should have started with. But because the sine and the cosine and so forth are not one-to-one functions, they're not perfect inverses. And it's important to remember, the sine of the inverse sine will always give you the same thing you started with. But the inverse of the sine only works to produce a value in this range. So if you weren't in that range to begin with, you won't get your right value. Likewise, the cosine inverse of the cosine only produces in its range. Every one of them has its own peculiar range. And these are the only two that are particularly important. The inverse tangent is very much like this, but it's not defined at the endpoints. The other three don't have a universal domain, so you just have to decide based on your book. And lastly, there's a few identities. One more that's pretty important. The tangent of x is going to be the sine of x over the cosine of x. The most important is right here. The sine squared of x plus the cosine squared of x is 1. That's by far the most important. The others, they're useful, they're less important. And that's all we have for today. I hope it made sense. Until next time.